Hi everyone, my name is Catiúcia and I am a professor at Federal Institute of Goiás in Brazil. So I'm going to present the poster titled Bi6Te2-xRxO13 system, where R can be titanium, silicon, or cerium, and an investigation for fuel cell application. It's known that fuel cells stand out between the renewable energy source. Among the different types are the solid oxide fuel cell, SOFC. This device uses oxygen-ion conducting oxide materials. The challenge is about the study of SOFC able of operating at lower temperatures, about 400 up to 700 degrees Celsius. The 3-bismuth oxide per 2-telluric oxide present two phases, the orthorhombic one and the high temperature cubic phase. This cubic phase is so interesting for this application, but there is a challenge about obtaining the cubic phase at room temperature. So, partial replacement of the tellurium ions in this system was done in order to stabilize the cubic phase. The samples were prepared by solid-state reaction. Two cooling rates were used, the slow rate and a quenching, and XRD and TG, the TA, were used by characterization. This is our result about the tellurium replacement by titanium. In this first heat treatment that is controlled cooling, formed a mixture of the orthorhombic, cyanide, and perovskite composition. In the second heat treatment, that is a quench rapid cooling, we can see the same situation, but the cubic phase was formed instead orthorhombic phase. So in both cases, there is not a single phase, but a mixture. That is a result of thermal analysis. This result shows us two important information about the cubic phase. There is a not stable phase because there is a peak, exothermic peak around 7 degrees Celsius that shows us is a not stable phase. So the third peak is a widest peak that is related to melting of the different components in the mixture. So we can see the cubic phase is not stable and there is a mixture in the compound. About the results, the tellurium replacement tellurium ion by silicon and cerium, we can see the same result. In this case, were formed a mixture and not a single phase. About the conclusions, the attempt to stabilize the cubic phase in this system resulted in mixture, not a single phase, when R is titanium, silicon, or cerium. Study with other cations to replace bismuth or tellurium are in progress, intended to stabilize the cubic phase in lower temperatures to fuel cells application. That's all. Thank you for your attention.